At this point, we're going to do integration of logarithmic functions. Whenever you have the integral of du over u, the answer is ln of the absolute value of u, absolute value of that, plus c. So if you have the integral of dx over x plus 5, if you let u equal x plus 5, well then du will be 1 dx or dx. So this integral, piece by piece, dx, well that's du, and x plus 5, that's u. Oh, I know that integral. The integral of du over u is ln of u plus c. But u is x plus 5. Here's the answer. Try some more. The integral of x squared over 5 take away x cubed dx. I would let u equal the denominator, because I kind of see the derivative of u on top. Du is negative 3x squared dx. Well, that part, that's u. No doubt in my mind, it's u. It says so right there. And x squared dx, that's what we have. If only we had a negative 3. Well, not a problem. If you need a number, not an x or an x cubed, but just a constant. If you need a negative 3, put it in. Now, all of that, that's du. Okay, du. Wonderful. But if you put a negative 3 in the top, you have to put a negative 3 in the bottom. But 1 over negative 3 is just negative 1/3. You never put the sign in the bottom. So what we have here is negative 1/3 times this integral. Here's a negative 1/3. Well, I know that integral. It's ln of the absolute value of u plus c, where u is 5 minus x cubed. There it is. Try another one. Suppose you have the integral of x dx or 3x dx over x squared plus 1. I always pull the constants out in front, just in case it's not the constant you want. I'll show you what I mean in a moment. Okay, so you have this problem. You let u equal denominator. Then du will be 2x dx. Well, there's my 3. This, of course, is u. Now, the top is almost du. It has the x dx, but it needs the 2. Oh, it needs the 2. That's not a big deal. I'll put a 2 in, but then I have to divide by 2. So what's in front is 3 over 2. This piece is du, and this piece is u, and I dealt with everything. There's nothing left over that I didn't modify. So this is equal to 3 over 2 times this integral. But I know that integral. It's ln of the absolute value of u plus c, and u happens to be x squared plus 1. Now, I claim that this is equal to 3 over 2 ln of just x squared 1 plus c. No absolute value. And the reason is that x squared is 0 or more. You cannot square a number and get less than 0. There are 3 types of numbers. When you square a negative, you get a positive. When you square a negative, you get a positive. When you square a positive, you get a positive. When you square 0, you get 0. The least you get when you square is 0. But then when you add 1, you're going to be at least 1. You're going to be at least 1. Well, if you're at least 1, then you're positive. The absolute value of a positive number is itself. The absolute value of x squared plus 1 is identically x squared plus 1. It's nothing else. So you can get away with that. And although I wouldn't write it this way, one can write this as ln of x squared plus 1 to the 3/2, because the number in front can go up as the power. If the power can go in front, well then the number in front can go up as the power. So either of those 2 last answers will get full credit. If you're in my class and you left it like this, you lose a point. You didn't simplify as much as possible. Here's an interesting problem. Suppose you have the integral of x plus 7 over x dx. Suppose you have that. Now, what's been happening so far, how I knew to use logs is, I may have had an x cubed in the bottom, and I had an x squared on the top. I know that when you take the derivative of x cubed, you're going to get an x squared. But here, if I take the derivative of x, I get 1. 1's not on top. You have an x on top. So what you should do is do the long division. X over x is 1 plus 7 over x. Well, that's 7 over x dx. Now this is just, whether you write this step or not, it's 1 dx plus the integral of 7 over x dx. Like I've been saying, constants put out in front. Okay, the integral of 1 dx is x plus 7. The integral of dx over x. Well, that's the same as the integral, well, remember the integral of du over u was ln of the absolute value of u plus c. Well, the integral of dx over x is going to be very similar. It's going to be ln of x plus c. The integral of dx over x is just ln of absolute value of x plus c. Ln the absolute value of x plus the c. And there's the answer. You had to do the division. You had to do the division. Sometimes you have to divide it. This problem. X squared of x dx over When you're multiplying and the bases are the same, you add the exponents. 1 plus a half is 3/2 over 1 plus, well, of course, that's x squared, and that's x to the half. And when you add 2.5, you get 2.5, which is 5/2, x to the 5/2. And then I say, you know what, 5/2 minus 1 is 3/2. That is, I'll let u be the denominator, excuse me, x to the 5/2, and then du would be 5/2 x to the 3/2 dx. I'm just missing the 5/2 for du. That is the bottom, we're done, that's u. If only I had 5/2 in front, then everything on top would be du. Well, you have to put 2/5 in front then. 5/2 times 2/5 is 1. I'm just multiplying by 1. So this is equal to 2/5, the integral. The top is all du, and the bottom is all u. Problem is done. It's 2/5 ln of the absolute value of u plus c, where u is whatever I said it is. Don't randomly guess. Look. It won't hurt to look. There it is. Okay, if you insisted on writing x to the 5/2 as x squared square root of x, that's also okay. That is, you could have written, the answer is 2/5 ln of 1 plus x squared square root of x plus c. Now if you think about it, x squared is positive, or it's not negative, it's at least 0, times the square root of x. The least that is 0. The least this product is 0, but it's having 1 added to it, so that's positive. You don't need to say absolute value. I'm just putting big brackets around it. And there's your answer. Try one more. Suppose you have e to the x on the bottom plus e to the negative x, and on top you have e to the x minus e to the minus x dx. Well, if you slip, you realize the derivative of the bottom is right on top. If you let u equal e to the x plus e to the minus x, du will equal, well, the derivative of e to the anything is e to the anything times the derivative of that anything. The derivative of x is 1. You don't need to write 1 in front. The derivative of e to the negative x is e to the negative x times the derivative of the negative x, which is negative 1. So you have plus negative 1 dx. But that happens to be e to the x minus e to the negative x dx. That's exactly what the numerator is. The numerator is du, and the denominator is u. Ooh, integral of du over u. I know that one like I know my name. It's ln of u, absolute value of u, plus c, where u is e to the x plus e to the negative x. The e to a power is always positive. This is positive, and we're adding a positive. That means what's in their absolute value is positive. So we don't need the absolute value bars anymore. There's the answer. Okay, that completes the section of integration of logarithmic functions.